Here we have a SAT math problem. Okay, let's go to the question. In the figure above, a line segment D, line segment FG, and line segment AC are parallel. So here the markings over here and here indicate, so all these three line segments are parallel. That is DE is parallel to FG and FG is parallel to AC. That means all the three line segments are parallel, and the length of the line segment AF, FD and DB are equal. If the area of this portion, that is AFGC, is 20, what is the area of this shaded region? Okay, actually it is a trapezoid because we know that FG and AC are parallel. Since one pair of the size of this quadrilateral are parallel, we can say this is a trapezoid. The area of this trapezoid is given 20. So we need to find the area of this trapezoid, FDEG. Okay, here, since whenever we have two parallel line segments inside the triangle, and also those parallel line segments are parallel to one of the sides of the triangle, then these two parallel line segments will divide the triangle into similar triangles. So that is the smaller triangle FBG is similar to the another smaller triangle DBE, and also these two similar triangles, the smaller similar triangles must be similar to the original triangle ABC. So since this line segment, all these three line segments are parallel, we can consider this BA as transversal. So here the angle measure over here, angle measure over here are corresponding angles. So B is a common vertex for all the three triangles. By angle similarity postulate, all the three triangles are similar. Okay, now let me write the vertex of the original triangle, that is ABC. So this is the original triangle, and let me write the vertex of the smaller triangle FBG. Let me write it FBG, and now let me write the vertex of the another smaller triangle, that is DBE. Let me write it. Okay, so here all these three triangles are similar. Let me write it. Okay, now let me assume the length of this line segment AF as just 1. What is the length of this line segment FD? That one also must be 1, and the length of this line segment DB also must be 1 according to this information. So what is the length of the side AB of the original triangle? That is clearly 3. So according to my assumption of just 1 unit for the line segment AF, so the length of the side of the AB of the original triangle is 3. Okay, what is the length of the corresponding side in the smaller triangle FBG? That is clearly 2. And what is the length of the corresponding side in the another smaller triangle over here DB? That is 1. So the sides of the three similar triangles are in the ratio 3 to 2 to 1. Okay, then what is the ratio in which we have the areas of the three triangles? So to get the ratio of the areas of the three similar triangles, what we need to do is we have to square the sides. Then I'm getting 3 square to 2 square to 1 square. So 3 square is 9 and 2 square is 4 and 1 square is 1. Okay, now I got the ratio of the areas of the three similar triangles. Okay, from the terms of the ratio of the areas of the three similar triangles, if I want to get the area of the first triangle, second triangle and third triangle, what I need to do is I have to multiply the terms of the ratio by the same non-zero number. So let me write the stuff over here. First, let me get the area of the original triangle, that is the area of triangle ABC. So for that, to get area of the original triangle ABC, I have to multiply the first term 9 by some non-zero number, say x, then I'm getting 9x. Then area of triangle, the second triangle FBG. So I have to multiply the second term of the ratio by the same non-zero number, that is 4x. Now to get the area of the third triangle, that is triangle DBE. So what I have to do is I have to multiply the third term of the ratio over here by the same non-zero number. 1 times x is x. Okay, now to get the area of this trapezoid AFGC, what I have to do is I have to subtract the area of this triangle FBG from the original triangle ABC. So we know that the area of triangle FBG is 4x. It has to be subtracted from the original triangle ABC. When I do so, I'm getting 9x negative 4x. So this expression gives the area of this trapezoid AFGC. That is already given in the question, that is 20. So it must be equal to 20. So 9x negative 4x is 5x. 5x equals to 20. If I divide both sides by 5, I am getting x equals to 4. Okay, now I can plug in x equals to 4 over here to get the area of the triangle FBG. When I plug in x equals to 4 over here, I'm getting getting 4 times 4, that is 16 is the area of the triangle FBG. And when I plug in x equals to 4 over here, I'm getting the area of the triangle DBE. So when I plug in x equals to 4, I'm just getting 4. Okay, now I got the area of the triangle FBG and also the area of the triangle DBE. If I subtract the area of the triangle DBE from the area of the triangle FBG, I'll be getting the area of this shaded region. So that is, I have to subtract the area of the triangle, the smallest triangle DBE4 from the area of the triangle FBG, that is 16. So 16 negative 4, that is equal to 12. So the area of this shaded region is 12 square units.